Electrical concepts form the backbone of understanding how electrical systems function. These concepts are applicable across various areas, from basic residential wiring to complex industrial installations. A fundamental concept is voltage, which can be understood as the electrical potential difference between 2 points in a circuit. Voltage is measured in volts and is often described as the electrical pressure that drives the flow of charge or current. Higher voltage generally means a greater potential for electrical current to flow. Current, measured in amps, represents the rate of flow of electrical charge. It's the number of electrons passing a given point in a circuit per unit of time. Think of current as the volume of water flowing through a pipe. A higher current indicates a greater flow of electrons. Resistance, measured in ohms, opposes the flow of electrical current. Every material has some degree of resistance. Conductors, like copper and aluminum, have low resistance, while insulators, like rubber and plastic, have high resistance. Resistance transforms electrical energy into other forms of energy, such as heat. Ohm's law establishes the relationship between voltage, current, and resistance. It states that voltage equals current multiplied by resistance, expressed as volts equals amps times ohms. This law is a cornerstone of electrical circuit analysis. If you know any two of these values, you can calculate the third. For instance, if a circuit has a voltage of 120 volts and a resistance of 10 ohms, the current flowing through it would be 12 amps, calculated as 120 volts divided by 10 ohms. Electrical power is the rate at which electrical energy is transferred or consumed in a circuit. It is measured in watts. Power is calculated by multiplying voltage by current, expressed as watts equals volts times amps. Knowing the power consumption of a device is essential for determining the appropriate circuit size and preventing overloads. For example, a device that draws 5 amps at 120 volts consumes 600 watts of power. Understanding series and parallel circuits is crucial for analyzing more complex electrical systems. In a series circuit, components are connected end to end, forming a single path for current flow. The current is the same through all components in a series circuit, while the voltage is divided among them. The total resistance in a series circuit is the sum of the individual resistances. In a parallel circuit, components are connected side by side, providing multiple paths for current flow. The voltage is the same across all components in a parallel circuit, while the current is divided among them. The total resistance in a parallel circuit is calculated using the reciprocal formula, which is 1 over the total resistance equals 1 over resistance 1 plus 1 over resistance 2, and so on. Grounding is an essential safety measure in electrical systems. It provides a low resistance path for fault current to flow back to the source, tripping a circuit breaker or fuse and interrupting the circuit. Grounding helps to prevent electrical shock hazards. The grounding system typically consists of a grounding electrode, such as a ground rod or water pipe, connected to the service panel and then to all metallic enclosures and equipment. Circuit breakers and fuses are overcurrent protection devices that are designed to protect electrical circuits from damage due to excessive current flow. Circuit breakers are resettable switches that automatically trip open when the current exceeds a certain threshold. Fuses are one-time use devices that melt and break the circuit when the current exceeds their rating. Selecting the correct size circuit breaker or fuse for a particular circuit is critical for ensuring safety and preventing fires. The National Electrical Code (NEC) provides detailed guidelines for electrical installations, including wire sizing, overcurrent protection, and grounding requirements. The NEC is updated every 3 years and serves as the standard for safe electrical practices in the United States. Understanding wire gauge and ampacity is also essential for electrical work. Wire gauge refers to the diameter of the wire, and ampacity is the maximum current that a wire can safely carry. The NEC specifies the ampacity of different wire sizes based on the type of insulation and the ambient temperature. Using undersized wires can lead to overheating and fire hazards, while using oversized wires can be unnecessarily expensive. When working with electrical systems, it's crucial to follow safety precautions to prevent electrical shock and other hazards. Always to energize circuits before working on them using a voltage tester to verify that the power is off. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work on live electrical circuits unless absolutely necessary, and then only with proper training and precautions. Three-phase power is commonly used in industrial and commercial applications due to its efficiency and ability to deliver higher power levels. Three-phase power consists of three alternating current waveforms that are offset by 120 degrees. This results in a smoother and more consistent power delivery compared to single-phase power. Understanding the different types of three-phase connections, such as Y and delta, is essential for working with three-phase systems. Transformers are used to step up or step down voltage levels in electrical systems. They consist of two or more coils of wire wound around a common core. The voltage ratio between the primary and secondary windings determines the voltage transformation. Transformers are used to transmit power over long distances at high voltage levels, reducing transmission losses, and then step the voltage down to lower levels for distribution to homes and businesses. Understanding motor control principles is essential for working with electric motors, which are used in a wide variety of applications. Motor controllers are used to start, stop, and control the speed of electric motors. Different types of motor starters are available, such as across-the-line starters, reduced voltage starters, and variable frequency drives. Variable frequency drives, or VFDs, are used to control the speed of AC motors by varying the frequency of the voltage supplied to the motor. This allows for precise speed control and energy savings. Power factor correction is the process of improving the power factor of an electrical system. Power factor is a measure of how effectively electrical power is being used. A low power factor indicates that a significant portion of the current is not being used to perform useful work, resulting in increased energy costs and reduced system capacity. Power factor correction can be achieved by adding capacitors to the electrical system, which compensate for the inductive reactance of motors and other inductive loads. Lighting is a significant consumer of electrical energy in many buildings. Energy-efficient lighting technologies, such as LED lighting, can significantly reduce energy consumption and lower electricity bills. LED lighting is more efficient, longer-lasting, and produces less heat compared to traditional incandescent and fluorescent lighting. Selecting the appropriate lighting fixtures and controls can optimize lighting levels and reduce energy waste. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges, which can be caused by lightning strikes, power grid switching, and other disturbances. SPD diverts surge current to ground, preventing it from damaging sensitive electronic equipment. SPD should be installed at the service entrance and at critical equipment locations. Understanding the principles of electrical troubleshooting is essential for diagnosing and repairing electrical problems. Electrical troubleshooting involves systematically testing different components and circuits to identify the source of the problem. Common troubleshooting tools include multimeters, voltage testers, and circuit tracers. When troubleshooting electrical problems, it's important to follow safety precautions and use appropriate personal protective equipment. Harmonics are distortions of the sinusoidal waveform of alternating current. They can be caused by nonlinear loads such as electronic devices and variable frequency drives. Harmonics can cause overheating of equipment, reduced power factor, and interference with other electrical systems. Harmonic filters can be used to mitigate the effects of harmonics. Electrical safety audits are conducted to identify potential electrical hazards and ensure compliance with safety regulations. These audits involve inspecting electrical equipment, wiring, and grounding systems to identify any deficiencies or potential problems. Regular electrical safety audits can help to prevent accidents and ensure a safe working environment. Arc flash is a dangerous phenomenon that can occur when a short circuit creates a high-energy electrical explosion. Arc flash can cause severe burns, blindness, and even death. Arc flash studies are conducted to assess the potential arc flash hazards in an electrical system and determine the appropriate personal protective equipment required for working on or near energized equipment. Electrical drawings and diagrams are used to represent electrical systems and circuits. These drawings provide detailed information about the location of electrical equipment, wiring, and components. Understanding electrical drawings and diagrams is essential for installing, maintaining, and troubleshooting electrical systems. Programmable logic controllers, or PLCs, are used to automate industrial processes and control electrical equipment. PLC are essentially specialized computers that can be programmed to perform a wide variety of control functions. Understanding PLC programming and operation is essential for working with automated systems. Renewable energy systems such as solar photovoltaic, PV, and wind power systems are becoming increasingly common. These systems generate electricity from renewable sources, reducing reliance on fossil fuels. Understanding the principles of renewable energy systems and their integration with the electrical grid is becoming increasingly important. The NEC Article 690 provides specific requirements for the installation of solar PV systems. Energy management systems, or EMSs, are used to monitor and control energy consumption in buildings and industrial facilities. These systems can track energy usage, identify areas of waste, and optimize energy efficiency. EMS can help to reduce energy costs and improve sustainability. Power quality is a measure of the quality of the electrical power supply. Poor power quality can cause equipment malfunctions, data loss, and other problems. Factors that can affect power quality include voltage sags, voltage swells, harmonics, and transients. Power quality monitoring equipment can be used to identify and diagnose power quality problems. Electrical codes and standards are constantly evolving to keep pace with technological advancements and address emerging safety concerns. Staying up to date with the latest codes and standards is essential for ensuring safe and compliant electrical installations. Continuing education and training are essential for electricians and other electrical professionals to maintain their skills and knowledge. There are many different training programs and certifications available covering a wide range of electrical topics. Investing in continuing education can help to advance your career and improve your earning potential. Understanding the concepts of electrical safety is crucial for preventing accidents and injuries. Electrical safety training should cover topics such as lockout/tagout procedures, personal protective equipment, and arc flash awareness. Implementing a comprehensive electrical safety program can help to create a safe working environment. The grounding electrode conductor (GEC) connects the grounding electrode to the electrical system. The size of the GEC is determined by the size of the service entrance conductors. The NEC Table 250.66 provides guidance on selecting the appropriate size GEC. Bonding is the process of connecting metallic parts of an electrical system together to create a low impedance path for fault current. Bonding helps to prevent electrical shock hazards and ensure proper operation of overcurrent protection devices. The NEC Article 250 provides detailed requirements for bonding. A ground fault circuit interrupter (GFCI) is a device that protects people from electrical shock by detecting ground faults. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. When a ground fault is detected, the GFCI quickly interrupts the circuit, preventing a dangerous electrical shock. An arc fault circuit interrupter (SI) is a device that protects against fires caused by arcing faults. SIs are required in many locations, such as bedrooms and living rooms. When an arcing fault is detected, the SI quickly interrupts the circuit, preventing a fire. Surge arresters are used to protect electrical equipment from voltage surges caused by lightning strikes. Surge arresters are typically installed at the service entrance and the critical equipment locations. They divert surge current to ground, preventing it from damaging sensitive electronic equipment. Electrical inspections are conducted to ensure that electrical installations comply with codes and standards. Electrical inspectors review electrical plans, inspect installations, and issue permits. Passing an electrical inspection is required before an electrical system can be energized. Electrical maintenance is essential for ensuring the safe and reliable operation of electrical equipment. Regular maintenance should include inspecting, testing, and cleaning electrical equipment. Properly maintained electrical equipment is less likely to fail and cause accidents.